Hi everyone, welcome back to our EV channel. Today we are going to do the practical demonstration or practical verification of Thevenin's theorem. Okay, so coming to the circuit diagram. So for the given this network, we need to verify Thevenin's theorem. Okay, so here you can see here the given network is an having 500 ohm resistor, 100 ohm resistor, and this is nothing but the load resistance where we need to find the current where this is nothing but IL. So in order to measure this current, we are directly connecting an ammeter in this branch. So coming to the practical circuit, this is the practical circuit. This is a 500 ohm resistor, this is a 100 ohm resistor, and this is the rheostat where you need to find the current in this branch. Okay, so now let us try to do it by first method, which is nothing but direct method. Directly we will not use any theorem, directly we will give the 30 volts and we will find the current in this branch, and we will verify with Thevenin's theorem also. Okay, now let us try to give the connections. So the positive of the RPS is connected to the positive of the board, the negative of the RPS is connected to the negative of the board, and in this branch I want to measure the current. Just connect an ammeter. So here the current enters, that's why positive, it goes to the positive of the ammeter, and the negative of the ammeter, it is connected here. Okay, and you can see here at the bottom there is no connection here. Then we will try to use a small short circuiting wire to make it as an closed path. Okay, so this is what the circuit diagram without using Thevenin's theorem. So here we have to apply 30 volts and automatically the current will flow in this meter. Let us try to verify. So the process of starting is initially whatever may be the condition of the RPS, keep the current knob in minimum and voltage knobs also in minimum. Just give the supply. As soon as you give the supply, so keep the current knob to the maximum position and slowly increase the voltage. As soon as you slowly increase the voltage, we need to apply an voltage of 30 volts and then go for fine adjustment. So approximately we have been applied 30 volts. So the applied voltage is 30 volts at the input port, and now you can see here the direct current. Okay, so 35, 36, 37, 38 milliamperes. So here you can see the tabular column. We have to plot the tabular column. So the practical values. Okay, so the current what you had got is 36 milliamperes is the practical value by direct method, and by Thevenin's you have to get 36 milliamperes. So this is the IL current by direct method, and this is the procedure to be followed for Thevenin's theorem. So these are the values what you have to get by Thevenin's theorem. So this we have to get by Thevenin's theorem. So directly we get that we had got 36 milliamperes. Now let us try to see here. We are going to do the parameters of Thevenin's theorem. Okay. First dismantle the given equipment. So now let's try to do it by Thevenin's indirect method. So first we have to find out Thevenin's voltage. How to find the Thevenin's voltage is very simple. Just apply 30 volts at the input of the port, and this is nothing but 500 ohm resistor. This is nothing but 100 ohm resistor. Just connect. Since it is open circuited, you will get only voltage. Connect to the positive terminal of the rheostat and negative terminal of this terminal, it will directly show the voltage. So since it is open, the voltage what is shown in the meter is only the open circuit voltage. The indicated voltage is 5 volts. So the open circuit voltage or Thevenin's voltage is only 5 volts. Okay, and next one we have to find out short circuit current. How to find the short circuit current is first remove the terminals of the voltmeter. So in this branch I want the current. Just connect an ammeter. Okay, so these are the two terminals of the ammeter. Connect to the positive terminal, connect to the negative terminal. Okay, so in this branch, so the current will not flow in this 100 ohm resistor, it will flow only through the meter. Okay, therefore then you are going to get the short circuit current. As you can see from the meter, you are going to get as 60 milliamperes. Therefore, you are going to have the short circuit current as 58 or 60 milliamperes. Now, so how to calculate R Thevenin is equal to V Thevenin divided by ISC. Already from for the practical calculation we have 5 volts divided by 58 milliamperes, then we can get the Thevenin's resistance as 83 ohms. Now we have to calculate it from the equivalent circuit. Okay, the equivalent circuit you are going to have. Okay, so this is the equivalent circuit. So here we have to apply VOC as 5 volts, and through this network you have to get the current as short circuit current as 58 milliamps, and this is the load resistance. So in order to construct this R Thevenin, so we are going to construct this diagram. See this diagram, you have an RPS and you have an resistor and you have an ammeter. So let's try to give this connection. Okay, so very simple, just remove the existing connections. So from the positive, so for this you don't require any board. So from the positive of the supply, you connect to the ammeter. Okay, connect to the ammeter, and output of the ammeter you connect to an rheostat. Okay, so this is the 500 ohm rheostat as shown in the circuit diagram. So you just connect in series. Okay, and the output of this you directly connect to negative. So very simple how to construct R Thevenin. You can see the circuit diagram how to construct it. So first you require an RPS and you require an rheostat, and directly you inject here. Okay, so see this diagram. So from the positive terminal it goes to the ammeter, and output of the ammeter it goes to the rheostat. Now how much voltage I have to apply here is VOC voltage. The VOC voltage is just only 5 volts. So apply an voltage of 5 volts by reducing the RPS. Okay, so as soon as you reduce the voltage, so you are going to have just 5 volts. So here it is 5 volts, and this is the rheostat, and vary it in such a way that a current of 58 milliampere current will flow, then this will construct a R Thevenin circuit. So now rheostat you try to adjust and see that it allows a current of 58 milliamperes. So this is VOC, and this connection is R Thevenin. Now we need to add the load resistor. So this is nothing but the load resistor. How to add it is, so just break the circuit and connect to this point and add the resistor. Okay, so this is nothing but the load resistor. When you add an load resistor in series to a arm, automatically current will decrease, and it indicates the current is 36 milliamperes. Okay, so that is what by Thevenin's theorem also you will be getting as 36 milliamperes of current. So it is very simple to understand, no need to bother. So this is VOC, this is nothing but the ammeter and rheostat adjustment will give you R Thevenin, and this is nothing but RL. So the formula behind the equivalent circuit of Thevenin's theorem is, here we have